You can register for part 2 of this series by clicking on the link in the description. And after you provide your name and email, you should be able to get access. It's absolutely free to watch part 2 of this series on demand on the On24 platform. What we cover in part 2 of this series is, controlling container resource consumption with control groups. We also talk about implementing access control for containers with AppArmor. And then we talk about limiting container system calls and performing vulnerability scanning for Docker containers. And we finally end by taking you through the process of building secure Docker images. So if you want to register for part 2 of this series, all you need to do is click on the link in the description and you should have access immediately. Hey guys, HackerSploit here, back again with another video. Welcome back to the Docker security series. In this video, we're going to be taking a look at how to secure the Docker host. And this process again is going to be multifaceted, and we're going to be, visiting various aspects of, securing inherent Linux vulnerabilities or misconfigurations, and then working on setting up, the various audit rules that Docker actually recommends. So let's just take a look at a few or a bit of theory before we actually get started. And there's a good reason for that. So firstly, what will we be covering in this video? Number one, we'll talk about, some of the best operating systems that you can use for hosting Docker. Secondly, we'll talk about minimal operating systems because, they're quite the talk nowadays. We'll then, take a look at auditing the host security using, auditing tools like Linux. And we're specifically referring to auditing the actual Linux distribution or the actual Linux server on which Docker is being hosted on. And then we'll take a look at, the process of securing and hardening the host operating system. So actually implementing some common security practices, not all of them. And then finally, we'll be focusing on creating the audit rules so that we can actually get our host operating system secured. And we'll finally run the Docker benchmark against the CIS Docker profile, just so that we can confirm what we've put in place has actually worked. All right, so let's talk about the best operating system for hosting Docker. Now, I just want to start out by saying that you should use whatever operating system you're comfortable with. Now, the reason I say that is because when we talk about other operating systems or other Linux distributions for that matter, many people don't have experience with other distributions or other distro-centric types of distributions and also distributions like CentOS. They're slightly different in the way they handle packages, so on and so forth. So again, make sure you use what you're comfortable with to begin with. And then of course, once you develop a skill with maybe a minimal operating system or cloud native operating system like Rancher OS, then you can switch to that. So again, I just want to point out that your Docker containers are only as secure as the host operating system. That's a very important thing to take into consideration, because if you don't have a secure host operating system and that host operating system gets compromised either through a vulnerability within an application that's being hosted on that particular server or through authentication protocols like SSH, then your Docker containers are also going to be part of that exploitation, and the attacker can then take control of the entire server. Secondly, the host operating system also needs to be audited and secured. So again, when I say this, I mean we need to audit the host operating system on which Docker is being installed or on which Docker will actually be utilized. We'll get to that during the practical demonstration. Thirdly, the host operating system should be as minimal as possible and should preferably be used for Docker exclusively. So what do I mean by this when I say your host operating system should be as minimal as possible? When I say that, what I mean is you want to make sure that the threat attack surface is as minimal as possible. So you want to make sure you're not hosting any unnecessary services like web servers or web applications or anything else that might be an attack vector that attackers could exploit or could lead to potential exploitation. So again, if you're hosting Docker on a server, ensure you only focus on hosting Docker on that particular server as opposed to running any other applications on it. That's essentially what I mean there. Now, when it comes down to minimal and cloud native operating systems, it's becoming clearer and clearer that they are the preferred method for production deployment of Docker. And the reason for that is because they're designed and configured to run containers. And of course, they're designed to be as minimal as possible because their only purpose is for hosting containers. So you have a much smaller footprint. And when I talk about footprint, I'm talking about a footprint in terms of resource consumption, and as well as the threat attack surface that I also mentioned. So they're only hosting one service and they consume relatively fewer resources than their counterparts, or as opposed to an entire operating system that is designed for general purpose use. So again, you can use any distribution you want. I would typically recommend using a stripped down version of that distribution, and many distributions have this option. And we will talk about this when we look at minimal operating systems. All right. So again, minimal operating system or cloud native operating systems like Rancher OS and Core OS, which I think is deprecated but is still maintained by Fedora to some extent, can be used to host Docker in production environments. That's where I really see it being deployed. And of course, this course this series is not really going to be focused on Rancher OS or Core OS. We're focused on the security aspect of Docker, and it's very important that we mention this. But we also have options like Ubuntu Server and Ubuntu Core, which are stripped down versions of Ubuntu that don't run anything extra, and similar to what we have with the Linode Docker host that we set up in the first video, where we don't have anything else running on it, and we're only using it for Docker. Now, of course, the next logical step will be to analyze it or perform an audit on it, a security audit on it, and then implement those recommendations to make the host secure, and then we can move on to the recommendations that are provided by the Docker Bench security tool. All right, now when we talk about auditing, which is the actual recommendations that were made in regards to the host configuration by the Docker Bench security tool, when we talk about auditing on Linux, the primary auditing system or framework that is utilized is the Linux Audit Framework. Now, what is the Linux Audit Framework? It's essentially a framework that allows us to set up various auditing policies for user space processes and programs. So, for example, if I have a web application, as part of security, I need to be able to audit all events pertaining to that web server. Now, you might be also asking, well, what is auditing in the context of security? Well, auditing allows us, to log and analyze all activity from a system or service. Why is that important? Because, when we have a service running, for example, or when we have users on a system, we need to be able to set up a system of accountability so that every action performed on that system, every file created, every file deleted, every file copied, all of that needs to be logged so that in the event of a breach or an issue, we can go to the audit logs and say, hey, this is what happened at this time and this user did it. So we have a system of accountability, which is extremely important in security. And as a lot of you are aware, accountability is part of the CIA triad, which is the confidentiality, integrity, and availability triad. That is sort of the primary axis of security when it comes down to information systems. So again, in terms of accountability, we need to be able to make sure that all the actions on the system are being monitored and are being logged. Now, when we talk about auditing, again, from a security perspective, we need to understand that auditing is not a preventative method of security or a preventative mechanism. It is rather a detective mechanism, or really something that happens after the fact, or something that you analyze after the fact, right? So, whenever you're talking about forensics, you'll typically see that a forensics team or an incident response team will check out the audit logs for a particular service or for a particular server. And that's very important for them because it gives them an idea of what happens. And that is why you nowadays have, or it's actually recommended to have, an off-site logging, centralized or even decentralized logging server where all your logs are being sent, so that in the event an attacker gains access to your server and then deletes the logs in order to hide their tracks, it really doesn't make a difference because the logs were sent as they were being logged. So that's something that I wanted to really explain. And of course, auditing is part of the core ethos of security when it comes down to actually detecting and analyzing accountability on a system and making sure that everyone or anyone on the system isn't doing anything malicious or isn't changing any particular files. All right, so we will use the recommendations from the Docker Bench security tool to actually create our audit rules. Now, as I said, we're going to be using the Linux audit framework. The Linux audit framework comes pre-installed on some Linux distributions, but in the case of Ubuntu, it doesn't. So we'll take a look at installing that. Now, let me explain how the Linux audit framework works, because it's going to be actually, pivotal to this particular video. So firstly, all auditing is handled in the kernel, right? So this is where all the auditing is handled. Now, you might be saying, well, how is that handled in the kernel? Well, let's say you have applications, right? And applications generate logs. And of course, if it's an important application like Docker, for example, so we can say Docker, right? And again, pardon my handwriting. So that is the application. Now, Docker will make system calls to the kernel, and these system calls are then analyzed by the kernel. And if they match any audit policy, then that particular audit event is sent to the audit log through the audit daemon or audit D. So you can see that is the events are then going to be sent to audit D, and they get stored within the logs here, which we can then analyze with tools like AU report or audit report or audit search or audit last, right? Now we are only going to be covering how to use AU report or audit report in this video, because the other tools are out of the scope of what we'll be covering, primarily because we're focused on securing Docker. But I just wanted to explain that. Now, when it comes down to the audit CTL, which is again, this particular utility is going to be used to manage and control the framework, and is also used to create audit rules. So that's very important. So how and where are audit rules saved? That's the key thing. Now, in this image, we don't have that annotation, but audit rules are usually saved in a file called audit.rules. All right. So they're saved in a file called audit.rules. And again, we use audit CTL to create rules, so they actually interact with each other. And on system startup, the audit daemon will actually look to the audit rules to determine the rules that we had set up. So that's also something that you need to keep in mind as well. All right, so that's in essence how the Linux audit framework works. And we'll be taking a look at how to use it shortly in the practical demonstration. Now, getting back to the actual presentation here, let us take a look at the auditing tools we'll be using in this video. So again, we'll be using the Docker Bench Security. We'll be using the Linux auditing framework. We'll use inspec. Well, we actually won't use inspec because we've already checked the results. We'll be sticking with the Docker Bench Security, and we'll be using Linux. Now, what is Linux? Linux is a security auditing tool for systems based on Unix like Linux, macOS, BSD, and others. It performs an in-depth security scan and runs on the system itself. So the primary goal of the test, this particular test, is to determine the weaknesses and to provide tips for further system hardening. So we'll be using Linux to secure the host operating system, and then after we're done with that, we'll go back to the results provided by Docker Bench Security and implement those recommendations so that we can completely secure our host as best as possible. That being said, that is going to be it for the theory presentation. Let us move on to the practical demonstration. All right, so I'm back on the Docker host. Again, I set that up in the previous video on Linode, and we've already installed Docker. And now our primary objective to begin with is to secure the actual host operating system, which is Ubuntu 20.04. All right, and the tool, as I said, we're going to be using is going to be Linux. Now, I've already covered how to use Linux, and most of the techniques regarding server security we have actually covered in our previous series with Linode, and a link to that will be in the description section. We're only going to be focusing on the important on the important changes and the recommendations that we need to take. All right, so we'll be focusing firstly on performing the audit. We'll then take a look at authentication security, as well as ensuring that access to the server is as limited as possible, or is only available to those that actually have access or should have access. So again, let's begin by installing Linux. Now, Linux is a package within the Ubuntu repository, so you can automatically install it that way. So we can say sudo apt-get install, and we say Linux. All right. and we'll hit yes. Now this is not going to be the latest version of Linux, and it's actually recommended to check out the to actually download the archive yourself from the Linux website. This is going to be part of the documentation for this particular video and will be available in the ebook as well. And you can see that you can download it directly from here, and this will be the latest version and you can use it that way. So in our case, we'll just be using the one that comes with the default, Ubuntu repositories. So now that we have Linux installed, the first thing we want to do is type in Linux audit system. All right, so we can get our initial benchmark. So this is going to perform a whole load of tests on the host operating system. And again, not all of them are actionable based on your deployment or the deployment of the server. So I'm just going to let this complete the test and we can see where we are in terms of our score. All right, so the benchmark or audit is complete, and you can see that our hardening index is at 56 out of 100, which is not too bad, but we can certainly do a whole lot more. So again, the way Linux sorts out the data is at the very beginning, you'll have the tests, and then of course, right over here is where it actually gives us the results. So again, it'll list out the results and they will be warnings. So for example, you can see that the version of Linux is old, which is fine, and then no password set for the single mode. And then of course it couldn't find 2 responsive name servers, which are issues that are really not important, but we can begin actually implementing some of these recommendations that it gives us here in regards to the host operating system security. So the first thing we want to do in regards to hardening our host is we need to add another user and stop using the root user. Now, of course, we will also add this user to the sudoers, or we'll add it to the sudo group so that that particular user has administrative privileges. We will also add this user to the Docker group so that we can actually run Docker without any administrative privileges, or we can run it without saying sudo. All right, so again, we'll just say user add, and we'll say we want to create a home directory for the user, and then we're going to say the username, which is Alexis, and then the shell is going to be bash. All right, and we hit enter, so the user is added. We can then display the users by saying cat etc password, and you can see we have the user Alexis there. And now what we want to do is we want to set a password for the user Alexis, so we say password Alexis. All right, and you can use whatever username you want to use, and I'll set a secure password here. That's always recommended. There we go. So we've set a password for the user. We also want to change the default root password, so we want to say password again for the root user, and I will also change that password. All right, there we go. So we've changed the passwords for both of the users, both the root user and the user Alexis. All right, so now that we have that done, we want to add these. We want to add the user Alexis to the sudo group, and we also want to add that user to the Docker group. So if I say groups Alexis, you can see we are not part of any particular group. So I'll say user mod, and we'll add this user to a group. We'll add him to the sudo group, and then we'll say the username, which is Alexis, and then we'll add Alexis to the Docker group, like so. And now if we say groups Alexis, we can now see we are part of the sudo and Docker groups. Fantastic. So of course this process will differ based on the distribution you're using. If you're using any other Linux distribution, the group that you want to add the user to is probably going to be the wheel user, or you can modify the permissions using the sudoers file, or you can make changes to the sudoers file that way. All right, so we've added the user. Now we can actually switch to the user Alexis. So we're going to say switch to the user Alexis, and we'll navigate to our home directory, which again, if I print it out, is going to be under home Alexis. All right, so now in terms of authentication, our primary means of authentication is through SSH, and we don't have any SSH keys, or we don't have SSH key-based authentication set up. We're currently logging in with a password, which we want to disable so that we can prevent our server or mitigate the brute force attempts on our SSH server. And of course, when we use SSH keys, we don't use passwords, and only the user that has the SSH key will be able to access this particular server. While we're doing that, we also want to limit or disable root access via SSH so that no one can log into the root user, which is again just as important. All right, so what we want to do now is we want to go back onto my local system now. So this is on my actual Ubuntu system. You can see it's Alexis at Ubuntu here. And I want to generate a new SSH key. So I'm just going to say SSH keygen, hit enter. And I'm just going to give it the default name, and I'm just going to overwrite that particular SSH key. I'm not going to use a passphrase for my key pair. And I'm going to hit enter, and now my keys are going to be stored under the SSH directory. So if I list out the SSH directory within my home directory, you can see we have the public key and we have the private key. All right, so we want to copy over our key, and we can do this using the SSH copy ID, and we then want to specify the actual we will just say the user is Alexis, and then get the server IP, and this will transfer it over. This will transfer the key over to the target under this particular user, which is Alexis. So that's the user we actually want to provide or set up key-based authentication for. All right, so we'll enter the password for the user Alexis via SSH and hit enter. And the key has been added, so you can see we can now try logging into the machine with SSH Alexis, and we should be able to log in without providing a password. However, we need to disable password-based authentication first. All right, so we'll go back to our Docker host server here, and I'll close up my terminal there, and we will modify the SSH configuration file, which is under SSH and SSHD config, and I'll provide my password there. And the first thing you can actually do is change the default port that SSH is actually listening on. That's a great way of actually mitigating almost half of the brute force attacks, because attackers will expect it to be on port 22. We want to change the log level to verbose. So while we're actually setting up our logging and auditing, we want to set this to verbose so that we get as much information as possible. For the login grace time, we want to give that to 2 minutes. Permit root login, we want to set to no. And the max amount of tries a user has per authentication attempt is going to be set to 2. And we can set the maximum amount of concurrent SSH sessions to 2. That seems fair. And now we want to also, we disabled password authentication? No, we haven't. So we want to go right over here to the bottom. There we are. So to disable tunnel clear text passwords, change it to no. So we will change password authentication to no as well. We also want to enable public key authentication. So there we are. We have public key authentication here, and we want to set that to yes, which is set by default. And we're looking quite secure now, although there are a few options we can actually disable here. TCP keep alive, we can leave that as is. We don't need to change that. We can change the client active, the client alive count to 2, and TCP keep alive. I think that's fine for now. So we will write the changes, and we can exit, and now we can restart. So we can say sudo systemctl restart SSH. All right, and that's going to restart SSH. Now, if I exit from my server and I try and log into the server again using SSH root and the server IP, I'll change this to Alexis. But let's try with the user root. I shouldn't be able to log in. So there we are, permission denied. If I now say Alexis, there we are, because I have added the SSH key, I can now log in without password authentication. And I now have a secured authentication to my server. Now you can go a few steps further and set up fail to ban, if you're using password-based authentication. But as I said, we've already covered all of that. So we'll just perform another benchmark again. And again, if you're interested in securing your server, you can check out that particular series. So we'll just run this with sudo, and we will run that again. All right, so the audit is complete and our score has increased to 61, which is fine. Again, most of these recommendations are not applicable, but we will actually enable most of them once we install the audit framework or audit D in a few seconds. So again, you can see some of the other options regarding the SSH configuration that we didn't change, like allow TCP forwarding. We should set that to no. We'll actually go through this process again. I'll go through it personally, but if you're interested in actually hardening your Linux server, you can check out our Linux server security series on that. But for now, I think this is fine. Once we've set up our auditing, we should be able to increase our score, and we can also install our malware scanner. I'm guessing the reason why we have our firewall installed is because we have the UFW, or the uncomplicated firewall, installed by default. That being said, we can move on to the next step, which again is regarding the actual Docker security bench. And what we need to do now is I'm just going to copy over, or I'm just going to move over the actual directory, which was under the root user. So we have the Docker bench. So move. I'm just going to do that recursively. So move root will navigate to the root directory. Well, actually, we can just get the actual Docker bench again for the user Alexis here. Instead of copying it over so that each user has it. So we'll clone the Docker bench security GitHub repository here, and we will get into that now. And we can begin the auditing process once more. However, in this case, we will limit our results to only display the host configuration. So it will only perform the checks for the host configuration. So again, let's get to that right now. All right, so we can do this by, again, running or just saying Docker, and we will want to prefix this with sudo. And of course, we have administrative privileges. And then all we want to do is we want to specify the configuration as the host configuration here. So that can be done by specifying the -c option. And then we say we only are interested in the host configuration. All right, so we say host configuration, hit enter, and it's only going to perform checks on the host. So we can see that, again, it's only focusing on the host configuration. Now for the check 1.1.1, we are not going to be focused on creating a separate partition for containers because that's not really interesting for us. We're only focusing on the auditing options, which we can see it actually tells us the files the files and binaries for which we actually need to create the audit rules for. So you can see we have the systemd docker.service unit file. We also have the dockerd, I believe the dockerd binary here, which should be under, this is the Docker configuration file, which makes sense. This is another systemd unit file for the Docker socket. We also have the containerd binary there. Which again is important. So again, we can start the process fairly simply, but first I just want to make sure that we have the correct dockerd binary because it isn't displaying here. So I'm just going to modify the actual tests here. So if I list out the directory here, you can see if we head over into tests, well, all we need to do is just modify one file, and that is the host configuration script. And we are looking for Docker. So again, if we say user bin Docker install audit d, yeah, so we are looking for the actual dockerd option, or user bin and Docker, because it's only scanning for that one. It isn't actually bringing that up. Which I think should be fine because that is the binary that we actually need to secure. We need to secure the Docker daemon, but the test doesn't bring that up for some reason. All right, so this is check 1.1.1, 1.1.2. This is the Docker daemon. So ID, and it checks it within the groups. So that is the check there. We then have Docker, the check 1.1.3, and this is the auditing rule for dockerd. Yeah, so that is set up correctly. All right, so user bin dockerd, yeah, that is set correctly. I'm just going to run the test one more time just so that I can actually identify it. Hopefully the last time was just a mistake. It looks like, yeah, there we are. So ensure auditing is configured for the Docker daemon. It actually has changed since the last time. So we can begin creating the audit rules for all of these binaries and configuration files, as well as the service files, the systemd service files. Now, the reason these are so important is primarily because they're again vital to the operation of Docker. So the Docker daemon is vital, containerd is vital, and any actions or any events need to be monitored and audited. So that's very, very important. Now, again, to get started with using the Linux audit framework, we need to install audit. So this can be done by saying sudo apt sudo apt get install audit, right? And we're just going to hit yes there so that it actually installs it for us. All right, so it's done that. We also want to make sure that this the audit service is started automatically on system startup. So systemctl enable audit. All right, we hit enter, and we can now check the status of the service. Like so, we can see it's active and running, and it's also loaded there. So that's great. So now we have audit installed, and that essentially is the Linux audit framework installation. Now we can determine the audit version by typing in audit and I think we say v or version. Let's actually see, some man audit let's see what gives us the actual version, because before we actually take a look at how to use it, I think we should be able to just say sudo audit that is version. It still isn't giving us the version here, but again, knowing the version isn't really that important, but we can also check and see whether we have AU report installed. So we can say sudo AU report, and this will display a list of audited events, since we installed audit. So you can see the number of changes in configurations is set to 3, and these are going to be for services for which audit rules have already been created. And of course, it also audits the number of failed logins, which again is an important aspect or an important piece of information. It tells us the number of users, number of terminals, etc., etc. All right, so we can see that we have all the necessary tools working, so we can begin creating the actual audit rules. So what I'm going to do is I'm just going to open up a tmux session here so that I can multitask, and I'm just going to rename this one Docker bench. So this is where we'll actually check our we will actually perform our audit firstly on the host configuration. So Docker bench security and host configuration, like so, and we'll create another session here still on the Docker server, and we can now navigate back and forth and create the actual rules for these particular files. So what I'm going to do is we will just browse up to the top here, and we need to run that with root, it seems. So I'm just going to run that one more time with root, and or with administrative privileges, and we can now navigate to the actual audit rules that we need to set up. So we need to set up auditing for the Docker daemon, so we can go ahead and do that right now. All right, so when it comes down to setting up the auditing rule for a particular binary or a particular directory, all we need to do is say sudo audit ctl. We then need to tell audit ctl to watch this particular binary. In our case, it's going to be user bin docker d, right? And then we want to specify the keyword that can then be used furthermore with tools like AU search or AU report, to filter out keywords. So in this case, we'll just call it Docker, right? And we hit enter, and that is going to create the audit rule for that particular binary, which is Docker D. Now, if we want to list out our current rules, our current audit rules, all we need to do is say sudo audit ctl, and then we type in L or -L, and you can see it gives us the audit rule here. So we can see it's user bin Docker D, and the keyword is set to Docker. All right, excellent. So what we have to do now is rinse and repeat this process for each of these binaries, unit files, and configuration files, as well as directories that are actually recommended by the Docker Bench framework. So again, we need to do it for run containerd, varlib docker, etc docker, docker service, containerd.sock, etc, etc. And what I'm going to do is I'm going to go ahead and do this and get back to you when I'm done. All right, so I think I have everything done now. So again, if you want to list out the current, or if you want to list out all the audit rules that we have created, again, all you need to do is type in, again, say sudo audit ctl, and we hit list, and that'll actually list out all the rules. Now, one thing to note is that these rules are not permanent. Now, the reason they're not permanent is, if you remember, when we were talking about the Linux audit framework structure, is that these rules need to be saved in the audit.rules file. So again, you can easily just copy them and save them, because if you don't save them to the audit.rules file, each time the audit D service is restarted, these rules will be wiped and you'll need to add them again, which is not, it's not actually conducive or productive. So you want to make sure you save them that way. Before we do anything there, I just want to show you that this does work before we run the check again. So again, to actually confirm that this does work, what we're going to do is we are just going to say, docker d, and can we list the version here? So there it gives us Docker version, so that we have actually interacted with the Docker daemon. So that should actually be logged. Now we can view this by saying sudo aur report, right? So sudo aur report, and then we specify the actual keys. So we hit enter, and you can see that the latest one, which was this one right over here, you can see we actually interacted with Docker D. Now, of course, you can get more information using AUR report, any of the other audit reporting tools that we actually covered within the presentation. But this is, again, beyond the scope. Analyzing logs is going to be beyond the scope of this series. So now that we know it actually works, what we can do now is we need to actually save these rules right over here. Sorry, we can actually just clear the terminal one more time so I can list them again. We need to save these into the audit, and we want to go into audit, audit.rules, and we want to paste in the rules here one more time, and now we have our rules saved. So we can just add a bit of a space there, and we can exit. So now our rules are saved, and whenever the audit D service is restarted, those rules will be persisted and will work irregardless. All right, so now that we've actually done that, we can now we can run the Docker Bench one more time. So, or the Docker Bench security utility one more time. So cd Docker Bench security, we launch the bash script here, and then the configuration is going to be host configuration, and we hit enter, and we actually need root permissions. So let me just provide root permissions here, and we can see we get a pass for most of them. Let us take a look at what actually did not work. The only thing that didn't, that we actually got a fail for, was the separate partition for containers, which was to be expected. But we have created the audit rules for each of these binaries, services, well, not services, binaries, systemd unit files, as well as the configuration files. So that is done, and we now get a score of 9 out of a possible 20. Well, that's not actually the total scoring there, but in any case, we can also check or perform our audit on the system. So sudo linux audit system, just to see whether we have any improvement in terms of the score, because we had set up audit D. So we now have an auditing system, and of course you can use audit D to create audit rules for more application services and directories that you want to monitor. All right, so we'll give this a few seconds to complete. All right, so the audit is complete, and it looks like we got a slight improvement. And the reason I think we have a slight improvement is because we installed audit D, but we have not configured auditing or set up audit rules for some of the more important services and binaries that it actually recommends. So what I'm going to do is I'm just going to go through these recommendations and secure it as best as I can, and then I'm going to run the audit tool. I'm going to run Linus again, and hopefully we should reach a score of about 70, which should be excellent. So again, I'll also use a later version of Linus, and we can then modify the name servers so that we get a much better score. But you can take a look at all of the tests here, and these will simply give you a status similar to the Docker bench security. So for example, you can see for the security frameworks, we don't have SE Linux, we don't have GR security. Those are all things that we can actually work on. Let us take a look at some of the other insecure services. The inetd service is insecure, so the tool actually gives you quite a good idea of how to secure your host operating system. So again, I'm just going to go through this and make the recommended changes and hopefully improve my score. Alright, so I've downloaded the latest version of Linus from their website, and I've extracted the tarball into my OPT directory, and I've made the necessary changes and followed the recommendations that it actually provided insofar as my deployment use case permits me to. And we can now run the actual test again. So Linus audit system. And we can run that, and again I'm just going to wait for this to complete, and hopefully our score should be above 70. Alright, so the scan or audit is completed, and we can check out our score, and it is now over 70, so we have a 72, which is pretty damn good. So that is going to conclude this video. We've been successfully able to secure and harden our host operating system. We've explored the various alternatives in terms of cloud native operating systems. We've also used the Docker bench security utility to perform a host configuration check, host security configuration check, and we were able to actually pass all our tests after making the necessary changes, which of course included creating various audit rules for the vital binaries, configuration files, and systemd unit files. With that being said, I'm going to be seeing you in the next video in this series, where we will be taking a look at how to secure the Docker daemon. A huge thank you to all of our Patreons. Your support is greatly appreciated, and this is a formal thank you. So thank you Shamir Douglas, Ryan Carr, Sandor, Michael Busby, Sid Saab, Doozy, Tafim Bari, Dustin Umpress, and Michael Hubbard. Your support is greatly appreciated, and you keep us making even more high quality content for you guys. So thank you.